Hi everyone, this is an engineer from NuMicro speaking. During the following period of time, I will introduce the USB PCB layout to you guys. So, let's get the ball rolling. According to the USB PCB layout, I'm going to introduce it in terms of three aspects. First one is placement, next one is routine, and the last one is impedance. So, let's start with the placement of parts. Clock and circuits about USB are given priority consideration within the placement of parts. The traces of clock layout are definitely the shorter the better, so the crystal should be placed as near to a microcontroller as possible. The part that USB needs is a USB connector, and the one which host needs is the VBUS power control. Both of them also should be placed as near to a microcontroller as possible. Take NuMicro M251 for example. Let's take a look at the crystal X1 first. It is placed outside the pin 45 and 46 of M251, and when pin 45 and 46 come out, the crystal circuit is in there, and the next one is the circuit of USB. There are two ports in M251. The first one is USB 0. It is also called USB high-speed port. Take USB high-speed host for example. J1 is the USB A-type connector, which is placed outside the pin 104 and 106 of M251, but there still should have a space to contact the circuit about power control of host VBUS. So that the placement of M251 high-speed USB post has done. U2 is the power control of host VBUS in the picture too. And next, the USB 1 of M251 is a full-speed device port. There is only one USB connector and two damping resistors for device port. For USB full-speed device, we place B-type connector outside the pin 98 and 99 of M251, but it still needs a space to separate with U2, which means it has to be placed at the edge of the board that underneath the U2. And then place two damping resistors near to the USB connector. When the placement is done, it is turned to actual traces. USB is a pair of differential signals, which are D plus and D minus. All the traces have to keep parallel, and their length have to be equal. If they are not equal, the ones that are not equal cannot exceed 200 mils. The width and the length of the traces have to be designed within the differential impedance of 90 ohms. I will explain it later. In addition, the signals of D plus and D minus have to be placed with M251 in the same layer, and without any bias and internal layer traces. If the traces must be turned, the angle of the turning point has to be 45 degrees. No matter the mode of the USB is host or device, they all have to comply with the above regulation. Furthermore, before deciding the width and length of traces, the calculation for differential impedance of 90 have to be done first. It can be calculated by a specific software. The parameters for calculation of impedance are the material and thickness of PCB, the thickness of multiple layers, and the width and the length of traces D plus and D minus. Because there is a ton of parameters for calculation of impedance, it is too professional to an engineer who does the USB high-speed for the first time. The calculation for differential impedance of 90 ohms can be left to the layout company. Just like I told before, the parameters for calculation include the material and thickness of PCB and the thickness of multiple layers. Therefore, after the layout company decides the width and length of traces, the parameters of PCB will be transferred to the manufacturer, and they will do the calculation with the same parameters again. So the parameters for differential impedance of 90 ohms from layout company and manufacturer can be cross-referenced. Finally, once the PCB has produced, we can ask the manufacturer to test whether the differential impedance has reached 90 ohms or not. So, these are the introduction of the USB PCB layout. If there are still some questions about it, please contact us without any hesitation. Thanks.